The gravity of the time is such that every new avenue of peace, no matter how dimly discernible, should be explored. Never before in history has so much hope for so many people been gathered together in a single organization. You will provide a great share of the wisdom, of the courage, and the faith which can bring to this world lasting peace for all nations and happiness and well-being for all men.
Hello to the Titans of Nuclear podcast listeners. My name is Suzanne Jaworowski. I'm the chairman of the International Framework for Nuclear Energy Cooperation, also known as IFNEC. This is the IFNEC mini-series on the Titans of Nuclear podcast, and we want to thank Bret and his staff for inviting us to present this mini-series that tells the stories of how nuclear energy is providing clean, reliable energy all around the world. Thanks so much for joining us. I hope you enjoy this special IFNEC mini-series. For more information about what's happening at IFNEC, please visit us at ifnec.org. Thank you and enjoy the podcast.
We're here today with Dr. Kamal Araj, the Vice Chairman of the Jordan Atomic Energy Commission. Welcome to Titans of Nuclear.
Thank you for
I'm so glad to be able to finally interview you. And as we like to do here, I'd love to start off to just learn about you and hear your past and how you got involved in this sector.
Well, I actually, after I have finished my bachelor degree in physics and nuclear engineering at University of Michigan, so I was very much from the early days interested in the nuclear energy. I finished actually my bachelor degree in plasma physics at University of Michigan Ann Arbor, and then went to MIT to finish my doctorate in nuclear engineering. At that time, I actually specialized in reactor engineering and as well as a minor in energy technology and policy. And actually have done my doctorate thesis on the global climate change.
Wow.
Back in
very relevant to our
1982. Yes. I realized my thesis supervisor, Dr. David Rose, who really an authority on plasma physics, have identified that these policy issues has to be tackled by scientists. Yes. So we actually have done a lot of interesting piece on that at that time. Essentially, there's understanding the role of nuclear energy has to undertake to mitigate climate change. And actually, we identified a lot of scenarios back at that time. We were talking about from year 2000, we should start undertaking a large buildup of nuclear energy around the world. Unfortunately, we even testified to the US Senate Committee of Energy and Natural Resources and testified on that effect, but probably at that time Carter came into power and things changed around. So it was not really much emphasis on nuclear energy.
Yes. And what were some of your initial conclusions? And given how science has progressed in the climate change sector, has that reinforced or has that changed what we've learned about nuclear's role?
No, not very much so. I mean, the question was the build-up, the capacity to build up nuclear energy at that time. No, historically, we were able to build like 50 gigawatt per year.
Amazing.
So you actually could fill 50 reactors per year, the combined capacity for the various manufacturers. I don't think now we're probably up to 15, down to 15. So, and the question was, at that time, we were trying to limit to around 450 parts per million, which actually to limit the carbon, the temperature increase to also 1.5 to 2 degrees centigrade. So there was really a drastic changes, and we realized, understand we have actually modeled the renewable energy coming at a very high rate, but still was insufficient to be able to mitigate the effect itself. The only, frankly, the same conclusions that we have predicted at that time are still valid. We see that there was a lot of variability in the seasonal changes that you see these tornadoes and quick changes in weathers around the globe. We predicted that at that time, and it's actually coming true. So we identified a lot of hotspots, and a lot of regions will be real losers, and there some might be winners, but still, I think the global humanity will lose as a whole.
I think so too. Yeah.
So there was a need to really to increase all the non-carbon releasing sources and to invest in R&D and development of these things. So I think we have identified a lot of these issues that now they're being tackled. And even we considered at that time we really should standardize the reactor design. You cannot really have 100 types of reactors going around the world. We're talking about massive construction program. So there should be a large learning curve, a lot of sharing of equipment, supplies. So to be able to reduce nuclear to competitive to the way it was in the beginning, we need to have these kind of standard measures and standardization of design, certification. Really, the vendors have to work together.
Yes,
there is enough business for all.
I couldn't agree more. You're preaching to the choir here. It's amazing to hear you say this because, you know, I've been interviewing people for years now, and I've come to the exact same conclusions. You know, standardization of the supply chain is the number one most important aspect to cost-effective nuclear. It almost, like, I don't care what reactor core you have, just build it the same way, use standard parts, make it manufacturable, learn from the combined cycle natural gas industry, which is able to put up a plant in 18 months. It's amazing. I mean, these are large facilities, but they can build them in 18 months.
Yeah, I think now the promise for a small modular reactor to reduce the construction time, but I still see a big variability and a very large range here. I mean, so that has to be reduced. Frankly, I think the only option is the nuclear industry has to work together. There's no, I mean, I understand competition is useful up to a stage, but then they should really share. These becomes construction engineering methods and best practices. These can be imported from other industry if the nuclear industry has not learned.
I agree. I think openness and sharing is so important in this. I mean, I'm not sure if we've told you, but we put up this Open 100 project, which is supposed to be this repository of nuclear schematics and best lessons learned. And I'll share this with you later if you'd like as well. But you're literally saying the exact same things that I've come to the conclusion of myself. It's amazing to hear you say this. So tell me about your role, though, and you talk about standardizing licensing. How did you come to your role at first today, and what can you do in your role in order to help push that agenda?
Well, you know, I have worked in the U.S. After I graduated from MIT. I worked at Brookhaven National Lab on advanced reactor design, actually on high temperature gas-cooled reactor, bubble bed reactors, essentially for nuclear propulsion and other innovative applications. And then I spent 2 years at Harvard, actually, as a visiting professor there, working on severe reactor accidents after the 3 Mile Island. So I have worked on this kind of severe reactor scenarios, the modeling for the US NRC. So this was funded for the American Physical Society. I worked on that for 2 years. And then I returned back to Brookhaven National Lab, still worked on nuclear propulsion. And after that, I moved to the US National Academy of Sciences, actually conducting studies on relevant energy technologies, advanced reactors, and energy policy. So after that, I moved to the IAEA, International Atomic Energy Agency, where I spent 5 years there in the policy planning group there. And from that, you know, Baradei was the Director General. I think there was a discussion to go back to Jordan, since I'm Jordanian, and work on the starting nuclear program in Jordan back in 2006.
Wow. And so what was it like going back to Jordan? I mean, you'd spent so much time traveling internationally, and you were here in the US, and then, you know, I don't know where you were for the IAEA, but it seems like you became a very international man.
In Vienna.
What was it like going back to Jordan?
Well, I think it was difficult as usual in the beginning, because there is a lot of apprehension about nuclear energy in Jordan, you know, a lot of consideration. But we really made the argument and the basis, and His Majesty King Abdullah II was very supportive of the program, and he thought that nuclear energy could actually advance the industrialization of Jordan and the capacity building and knowledge for advanced technologies and
just like South
that.
Korea,
So,
right? It was a huge game changer for their
Yes.
economy.
Yes, but here, the problem is that we have a lot of naysayers here that they always compare the cost of natural gas to nuclear, or now the very low prices of renewable, which nobody knows how to actually calculate. And I think this is really misleading.
Why is that? Can
They-
you articulate for me and our audience why it's so difficult to calculate the true costs of renewables?
Yeah, because the way they negotiate a power purchase agreement with the taker here, and this is they calculated by the developers of the technology, but still all the costs of system connection and all system stability and grid stability, all of that, and at night the backup power for this all taken by the government. And we have to burn diesel or natural gas at night at higher cost here. And this they don't take, this is the government undertakes. And the technology developer already get paid for its electricity during the daytime. And here in Jordan, the price is fixed, by the way. So there is no difference between day and night. And they get very good prices. They make a very high IRR, internal rate of return. And still, we entail probably 5 to 6, 7 cents per kilowatt hour system cost and interconnection. And that they should be paid by these renewable energy technology providers. Why should the government undertake this? So we have to keep all these natural gas on standby, on hot standby, because whenever the sun is shadowed or we lose the wind, so at night you have to provide you cannot just depend on renewable. And now they want to increase renewable from 20% presently to 31%. Wow. And by 2030. This is very high. And I think it will create a lot of instability in the grid. We noticed a lot of that during the COVID-19, because we didn't have much demand. So the portion of renewable was very high, and the system integrator had to shut down a lot of the renewable.
It's a curtail, yeah.
EVs, yes. Oh yes, because there was too much intermittency in the system. Yeah. So all of this, people don't see that if you have a large load anyway. Yeah. And I think this is the advantages of base load, like in nuclear. And we need to shift from fossil fuel. You cannot just depend on natural gas. I mean, understand natural gas is cheap now, but still the prices will go up and will continue going up. And since we need to reduce CO2, you have to move away from carbon dioxide. There are a lot of other applications in the chemical industry and feedstock for natural gas that are higher value added than just burning it.
Yeah, of course.
So I think there should be a thinking about beyond that. You need to develop these technologies. Why not developing it now and deploy it? We are able to do it.
So tell me more about when you came back to Jordan. Was there already a political consensus? I mean, so they brought you back because you're a world expert. You're Jordanian, so they wanted you to be part of this movement. But how did it come about politically to begin with? Were there other people that had large political influence?
Yes. The chairman, Dr. Khalid Touqan, is a foremost authority on this as well. He was in Jordan for a long time. He also an MIT graduate from nuclear engineering. So he's been shepherding this program since the 80s. Actually, he's been promoting, but there was a department in the Ministry of Energy. So when I came back, we established in 2008 an independent commission, the commissioners appointed by the king. So I was appointed the Commissioner for International Cooperation. Dr. Touqan was the chairman. I was also the deputy. And we had other commissioners responsible for the nuclear fuel cycle and applications. So they were all appointed by the king, very high level positions, and we established the commission. And we also immediately established the regulator. So a regulatory body was independently spun off and became an independent authority that also report to the Prime Minister. We also are reporting to the Prime Minister till now. So the commission had a lot of activities. We also undertaking uranium exploration program and a research reactor. So now we have in Jordan a research reactor of 5 megawatt is operating, producing radioisotopes.
And how did that come about? Did you guys build the research reactor yourselves? Did you have help from another country? How did you get a research reactor?
We actually had the tender for that, and the South Koreans, Kerry, won that tender, and so it was built as a turnkey by the Koreans. But now it's 100% operated by the Jordanians.
Amazing. And what does this research reactor do? Does this serve as a hub for nuclear knowledge where you can train people and help them understand how a reactor works and get them excited about nuclear technology so the whole program can be advanced?
Yes. This reactor, is really a cornerstone for our human resource development and also for research and development. So we put that reactor on the campus of the Jordan University of Science and Technology, where we have established a bachelor degree of nuclear engineering. So these students get hands-on training on reactivity, reactor control rod work and other applications. And we also open it for the university researchers to do researches on neutron activation, on solid state physics, and other things they can do. We also producing radiopharmaceuticals like iodine-131 and molybdenum-99, so technetium-99 as well. So this is an activity that we do to service Jordan as well as for training and education. And we will train, actually, the potential operators for the nuclear power plant will get hands-on experience on the research reactor.
And how is the research reactor licensed? And what does the licensing process look like for a commercial reactor right now?
Well, the licensing for this was done by our regulator, which is the Energy and Mineral Reactor Commission. And they followed essentially US NRC approach, but the one-step approach, essentially, the two-step approaches. So we had to get a site license for the reactor. We had to do an EIA. And then after the site license was obtained, we applied for the operating license. So construction license and operating license. So it followed essentially US NRC, and they had a consultant from the US, which were former US NRC commissioners, were acting as their advisors. And the Koreans also used their regulatory body to assist also as a TSO.
And would that still be the same case for if a commercial reactor was brought to Jordan? Would it still follow that same procedure, or has there been some advancement in the licensing process?
Well, as you know, in Jordan now we're focusing on small modular reactors. So we have abandoned the idea of large reactor for at least this second decade. For I think up to 2035, I don't think we could see a need for 1,000 megawatt. So we go for small modular reactors. And we thought that we could have really certification of design by the country of origin that we can apply in Jordan. But in the absence of that, we will have to depend on the country of origin licensing authority. So to work with our regulator, and perhaps we can build on the licensing documents. And so we would like to get, for example, all the licensing documents and the PSAR and all of that in advance. And perhaps, so we're not looking for first of a kind, we're looking nth of a kind. So hopefully we can borrow the whole licensing process and look at specific changes from the site specific only and only license those, hopefully. So we could probably shorten the licensing
Yeah, that's
process.
one of the things that I'm curious about. And constantly as I meet with people around the world, I try to explore this idea, do we have to stick to the same old way of licensing? Because it seems like we're stuck in an old mentality about the risks and the dangers of nuclear that were baked in for many, many decades. But now we've got so much more practical experience. Like, with Fukushima proved that 3 gigawatts worth of light water reactor could melt down and not hurt anybody. To me, it seems like that should re-inform how we think about licensing reactors. Not make it more strict, but make it a better understanding of the actual risks associated with nuclear. Is there any thought about shifting the mindset a little bit?
Yes, frankly, we are trying very hard to do that. But still, I mean, Jordan couldn't take a leading role in that. And I think we need to, talk to the countries like US and Canada to take the lead, or France and UK,
Yes.
I think. It's important to rethink the whole risk profile for
Yes.
nuclear. Frankly, I mean, if we apply the same concepts of nuclear, you would not license any industrial facility in the
Anything.
world.
You couldn't license anything.
You wouldn't be walking in the streets. You couldn't be
That's right.
driving.
You couldn't walk down your own staircase at home.
Really, no.
But
it is really unfair.
But this is one of the problems that I've seen is that I'm getting very frustrated in the U.S. because a lot of people look to the U.S. for leadership, but because we're so big and bureaucratic and stuck in our ways, it's hard for us to take a leading role in a transformation around especially how we regulate nuclear. For instance, one of the things that I think should be a no-brainer is if you have a less than 1 megawatt reactor even, and it's sitting in the bottom of a pool, you should be able to license that in less than a year, and for less than $1 million, because you run a few calculations. It only has this much decay heat. It can't go supercritical. The pool is very big. It seems to me like this should be like very easy, like signing off an architectural drawing for a building. But I don't think we can get to that place in the U.S. And it might take a more smaller, nimble country to get there. What do you think about that?
No, that's true. I think the problem is that this is the problem with the US NRC. I mean, frankly, now I see the new leadership is different. They're more risk informed and they would like to discuss that. But still, there are a lot of really hard, iron-clad rules that are in these documents, For example, the evacuation planning, 10 miles. I understand I know where this came actually. I mean, I was involved in that back to MIT actually, since my professor was Rasmussen, the author of the WASH 1400. They did all the risk probabilistic PRA. This was really out of the hat. Commissioner decided to have the 10 miles. This should be on based on risk. Frankly, for SMR, should be zero. There shouldn't be any evacuation.
And why can't Jordan then take a leadership role on saying that? Why can't the Jordan regulator say, we believe that SMR should have a zero mile site perimeter?
I am from the promoter, and we were going to make that argument. We're not going to have any evacuation. And we will prove that by sheltering indoor is much safer than evacuating people and they have accidents. Yes. This is very clear. Actually, I mean, since I was in Brookhaven National Lab, I was a witness actually for the Shoreham, nuclear power plant.
And by the way, I grew up on Long Island too, so I was also a witness in that sense.
I made the argument even for that reactor. This has a very, very, very large, robust containment building. There is no way it could have this ever failed. So there is no point of evacuation, ridiculous, I mean, there's no way to evacuate in Long Island. And the sheltering would have been, but look, I mean, this reactor was built $10 billion or whatever, and it was sold for nothing.
It's so crazy because I spoke to the former CEO of Long Island Power Authority at the time that Shoreham was being built. Well, I spoke to him recently, but he was there when it was being built. And he said the original cost of the building was only $500 million. So, and that's for 800 megawatts. I mean, that is nuclear power that is so cheap that it could save the whole world. And but he said with legal costs, it cost $2.5 billion extra dollars, just legal costs after it was already finished being built. Which is crazy. It's like we've shot ourselves in the foot.
No, I think there ought to be a large reduction in the cost of nuclear. The capex is too high. Frankly, shouldn't exceed $2,000 to $3,000 a kilowatt electric. Yeah, this is the right. I mean, at the time nuclear came, we were talking about 1 cent to 2 cents per kilowatt hour. It was cheaper than coal.
And so, what do you think about that as you look onto the landscape of technologies out there, the small modular reactor approach? Do you see them being able to achieve such cost reductions? Why not?
Not with this present. I mean, we have done an evaluation of all the SMRs, most of the SMRs that will come into the market in 2030. Actually, the cheapest cost was 10 cents per kilowatt hour. And even with a very low interest rate and discount factor. So I think it's important to rethink the whole financing for nuclear power.
Yeah.
I make the argument that this is actually nuclear power should be treated like a global common. It's because the carbon dioxide is a global common problem, and we are deploying nuclear energy as a global common mitigation strategy. Should be able to have very low cost for financing nuclear. This should be.
But why?
Yes, that could reduce the cost.
Why are they having trouble? It still bothers me that they can't compete on their own merit, even without government assistance or without government financing. If they can build combined cycle natural gas facilities so cheap, why can't we build nuclear so cheap? Is it our engineering that's bad? Like what? And we were able to do it back in the 60s. They were so cheap. Like I was saying, a few $100 million for a 500 megawatt or 600 megawatt facility. Where did we go wrong? Like, why can't we just do what we did back then?
Yeah, I think it looks like in the nuclear, I mean, we are actually going the reverse of the learning curve. We're actually forgetting the curve type. Now they're going into the SMR manufacturing and factory manufacturing and all of that. But frankly, the nuclear industry could have applied this from day one, even for large reactors.
Yeah.
I think they keep increasing the size of the reactor. Maybe this was the fatal mistake, essentially increasing the size, and they didn't really standardize. I think if they standardized, we could have achieved those goals.
Yes.
But frankly, we need to go back and rethink the whole thing. This is unacceptable. There is no way you're going to build a reactor with $7,000 a kilowatt.
Totally unacceptable. Totally unacceptable. So,
unless you have zero financing and zero interest rate, perhaps, yeah.
So tell me, in your current role today, are you constantly looking out at the landscape for new ideas and new technologies and new vendors?
Yes.
And what does that process look like? Walk me through your day-to-day.
Well, what we are doing now, we have actually looked at the whole nuclear SMRs globally. And we selected what we think can build in Jordan. And we were aiming to have this to be commercial 2030, 2031. So we have not looked at far designs or liquid metal reactors or molten salt. Though we were, the prices for the molten salt is really very attractive. They're claiming 4 cents to 5 cents a kilowatt hour. But still, we think there's still high risk for these kind of reactors, maybe in the future. So we wanted to focus on high temperature gas-cooled reactor and light water reactors. We mainly focused on these. So essentially, we are interested in NuScale, for example, this interesting design, XE100, which is high temperature gas-cooled reactor in the US, GE 300. This is also they claiming very attractive price based on their large reactor. Very simplified design, reduced a lot of the equipments and manufacturing material. But we still have to check that design carefully. And we're looking at the Chinese HTG RPM, which is under construction now. Next year it will be operational. So this is the far removed, far advanced reactor in the world in SMR. Also the Russian Rhythm 200, in which is the previous one, the forerunner of it was the icebreakers, and now there is 2 reactors like that is operational, similar to it. Smaller design, 37 megawatt. The one we'll be looking around 50 megawatts.
These are the floating power plants.
Yes, but they intend to build it on land as well.
Good. And so what's the
so we have also
the business model though?
Yes.
Is there some expectation of cost sharing between the developer and the host country?
Yes.
And my question is, why don't any of these developers offer it as a turnkey product, where they take on if they're so sure about their costs, why don't they take on the risk? Especially a company like NuScale backed by Fluor, which is a many billion-dollar company. GE, many billion-dollar company. why don't they take on the risk, and then once it's done being built, then they hand it over?
We actually have one company, X Energy, offered us
Yes.
such a deal. That just give us a power purchase agreement at this price, and also make contract for the fuel, and you will have this. That's
Amazing.
one option.
And is that going to work? Is that going to go through? Are there any barriers to that, or can you just let them build it?
No barriers. The only barrier is this: the power purchase agreement. I mean, the price they want is still much higher than the renewable or the natural gas in Jordan. So I think we need to negotiate with our off-taker, be able to.
What's a
convince
good
them.
price? What in Jordan is a competitive price against natural gas or renewables?
Well, there is no way you can compete with the pipeline natural gas at the current pricing. Although I think the prices will go up, but still at the current prices, we're talking about 6 to 7 cents the natural gas. So I think 8 to 9 is a good price for nuclear that could justify it. You can give a carbon tax credit or a tax on the natural gas and to give it for the nuclear. And I think there ought to be some kind of government intervention for that. Because nuclear will create a lot of social economic impacts in the country, and it cannot be calculated like natural gas. And also natural gas, we import natural gas from our neighbors. That, in 2009, it was interrupted 15 times. And we actually lost. Till now, they're paying losses, which is $6 billion. They lost because they had to turn to use diesel instead of natural gas, and the government had to subsidize it. They could not charge 18 cents or 20 cents for the customers.
Yeah, you'd think that you would have knowing that type of stuff happens, you have to factor that into the cost of natural gas. Yeah.
Right. So security of supply. I think there should be a price like cents per kilowatt hour for security of supply, and for carbon reduction, and for social economic impact, because
because there are cascading effects. If you turn off the power, or if the power even just becomes too expensive in an area, what if the manufacturing plant has to shut down, and that hurts their business and they lose business forever maybe?
Yeah, because the only measure of these things they use is levelized cost, which is really ridiculous.
It is ridiculous.
You cannot just know the price of electricity. And this is just, discount everything in the future, And nuclear technology, and these are long-term problems. These are long-term assets, Fortunately for natural gas, it's $1 billion for 1,000 megawatt, yes? I mean, it's very cheap.
Yeah.
And can be built in 2 years.
Yeah. No, it's amazing. I wish the nuclear construction industry could learn from the natural gas construction industry.
Yeah, but I think now we have the global climate change and the disaster that could come from that. And especially for a region like the Middle East, it will be the hottest region in the world. And with a lot of problems. I mean, I think we have a lot of water shortages in Jordan. This is a major constraint on our really nuclear thermal power in Jordan, because you need water for cooling. And this is a difficulty to find enough water.
Is there any way to use, like Palo Verde in Arizona, I believe uses wastewater, or it's like hooked up to the wastewater treatment plant to be able to use that for cooling. Is that a possibility as well in Jordan, perhaps?
That's exactly what are we doing in Jordan. We will be using the same concept like Palo Verde. I visited Palo Verde twice. And I think this is a very good example. And even we took members of our parliament to Palo Verde to show them that this can be work. You have 3 reactors. Actually, it was one of the largest power sources.
I think it's got to be one of the largest,
And, these were large combustion engineering reactors, probably each one 1,400 megawatt or so. And and it is in the desert. And I think like the pipeline was like 65 or 40 kilometers from Phoenix. And it's amazing. And one of these anti-nuclear members of the parliament said, this is just one case in the world, a unique case. I said, come on, it works. What's so unique about it? It's engineering.
Yeah, it's amazing. So you mentioned there's some anti-nuclear people. How does that work politically? Do you have to build consensus? Is it top down? How do you get things through in the nuclear world if you've got political opposition?
Frankly, I think some of these political opposition are essentially propped from outside. They're not really local indigenous sources because they tend to, maybe go visit to certain countries who are anti-nuclear, and they get a lot of information, from them. And, look what they're doing with the waste in these countries. They're very more developed than Jordan, and they cannot get rid of the waste. How Jordan can going to do with the waste? They always ask these questions, and definitely these questions are not coming from them. They're coming from these nuclear experts in these countries who are anti-nuclear now. And, I said, listen, we will deal with the nuclear waste like every other country. We will follow the US. We can store the nuclear waste on site till there is a solution. There is almost 100 technical solutions for the waste. Frankly, I think it's a waste to get rid of the waste. I think at this time, the waste is a resource of fuel, and we should use it.
It's almost magical in its properties. It's like we're transforming normal metal that you get out of the ground, and then you're giving it like magical special properties, which could be used for so many things, for their energy production, tracing devices, medical ice. I mean, there's just so many things that you can use when you make an atom radioactive. We've given it a bad name, but I think we should change the name. We should call it magical. We made it a magical atom.
I think there are a lot of misunderstanding, and some already is bad faith, really. I mean, it's like theology, some of those anti-nuclear. It's impossible to talk to them and convince them. We try a lot, and unfortunately, the anti-nuclear lobby is very rich, I suppose. A lot of these foundations, especially German foundations, they sponsor a lot of those people to go to Fukushima and to go see what happened in Fukushima? There wasn't... much fatalities to talk about. Most of the fatalities were during the ill-thought evacuation and the ill-thought that. Really, the actual accident didn't really lead to much. And it's just a lot of fear-monger here and causing a lot of apprehension in the public eye.
And do you think, I agree, and more broadly, I think it's definitely hurt the nuclear industry in many places around the world. Do you think that that'll have a very negative effect in Jordan, though, or do you think Jordan can overcome those forces and still push a positive nuclear agenda forward?
No. I think the problem is that with the nuclear, it's becoming like this is why we became like a whole community is really stuck together, because if there is a failure one place, it will be reflected in Jordan. We had no problem with nuclear till Fukushima. Till Fukushima happened, was turned. We had thousands of questions. What happened if you lose the coolant? Like Fukushima, they had the ocean. They couldn't cool the reactor. You have to really go and explain all these details here. They assume all the reactors are the same, and the whole phenomena is the same. And I think this is overblown. Frankly, nuclear, even second generation, is safe enough. We are going into third generation, fourth generation. Maybe with a larger number of large reactors installed in the world, you need a higher safety level. I understand that, but still, overall, should be in consummate with the other industries. We cannot price ourselves out of the market. It has to be. Risk is risk. One fatality, any place is fatality, from any industrial accidents, chemical accidents, oil refinery, whatever, natural gas distribution system, you need to look at the total risk picture and make appropriations for funding accordingly and the allocation of that.
That's what
And I think we don't do that.
I agree. And one of the things that I'm afraid of is not enough people have that same mentality. I also feel Gen 2 was safe enough. If it can't kill someone, how is that not safe enough? And then, but then you have the main developers, let's say like Westinghouse or Areva, with their Gen 3 Plus, they decided to make it $10 billion more expensive than it needs to be to achieve another like fictitious decimal point of safety. How do they not see that? How do they not reconcile the fact that they've priced themselves out of business?
Yes, I think it's really difficult to understand how this happened. But frankly, we should avoid it now for at least the SMR and the Generation 4.
Yes, I agree. Very good. Well, okay. What else should we cover? Are there other interesting things that you see happening around the world or in Jordan in the nuclear sector?
Well, I think, one thing I wanted to mention to you this about IFNEC, the International Framework for Nuclear Energy Cooperation. And, you're familiar with that. With Jordan, we are really a very long-term member for that. We joined from the very beginning for that. And we actually hosted a workshop on SMR in 2014 in Jordan. So we were quite involved in SMR in the very beginning. Look, this was 6 years ago. And still we were following this technology. And it's important to have this international cooperation between developed and developing countries and between newcomers and advanced countries. And I think this kind of forum, like IFNEC, in which every country have the same vote, and the same voice, it's important. And I think a lot of things has accomplished this cooperation. And I think this is a good forum in which we can discuss all these issues. Unfortunately, we don't discuss the licensing too much for that. But frankly, it should be discussed. We invite the regulators at some of the sessions, but still, they don't participate as strongly as the promoters and the government authorities for that.
Yeah. What would you, are there specific regulators that you think play an outsized role? You mentioned before that the NRC in Canada should maybe take some leadership, but are there others around the world that you think are maybe more forward-thinking, more nimble, have a good base for licensing?
I think UK and Canada, UK, and will be, I think, as well, perhaps Finland.
Yeah. Good. Kamal, as we wrap up today, maybe you can just leave us on a note of what's possible. If you were to look forward 10, 15 years and see an optimistic version of the future where everything you want to have happen comes true in the nuclear sector, what does that world look like?
Well, I think very important that we should down select essentially from the SMR to one or two designs, standardize these designs, certify them internationally or standardize their design as well, and then create enough global supply chain for that, and try to really by deploying this internationally reduce the price to affordable and competitive with natural gas. I think this is the only way to penetrate the impasse from other competing sources which are not really environmentally friendly. So we need to do that. And I think it has to be nuclear industry has to work together cooperatively. This is not really, I know they understand the vendors would like to make a profit and all of that, but still, I think it is serving an international global common problem, which is the global atmosphere and climate change. And it should have really higher value now attached to it as its contribution to humanity and to civilization worldwide. We need to break from this logjam of competitive and no, we can steep the competitiveness as the pre-competitive stage, but still, I think there is enough business for all the vendors, they should. But also, I think the vendors one time issued a code of ethics. I think they should go revisit it and probably revise it now.
Kamal Araj, thank you so much for your time, joining us and sharing your insights.
You're welcome.
Bye-bye.
And initiate at least a new approach to the many difficult problems that must be solved in both private and public conversation if the world is to shake off the inertia imposed by fear and is to make positive progress toward peace.